For this experiment you will need a retort stand and a rod clamped 90 degrees to that retort stand. Both the rod and the stand should be made out of aluminum to eliminate any stray magnetic fields that would interfere with this experiment. You'll also need a long straight wire. A meter stick lined up along the Earth's magnetic field line. Here is a compass just to align the meter stick. You can see it's right along the Earth's north-south magnetic field. A power supply. This is a Sigmatron Model 114. We also need a magnetic field probe, a LabPro interface, and a calculator for all the information to be stored in. For this experiment on the magnetic field probe amplifier box, make sure it's set to the high setting, because these are very small magnetic fields that we're dealing with. So make sure this toggle switch is set to the high position on the amplifier box. For the magnetic field probe, the field is detected as it goes through this white section on the probe. You have to make sure that that white section is vertical at all times. So when it's set up, the probe should look vertical like this. You can see the wire connected to the positive end of the power supply there. The wire goes down and then up, so that means the current through this wire will flow from the bottom up. Now, using your right hand rule number 1, with your thumb in the direction of that current flow up, you can figure out the direction of the magnetic field around the wire. For this first lab, magnetic field and current, we take the detector at the 3 centimeter mark, making sure the white spot on the detector, which detects the magnetic field, is vertical. The program we use is MagWire. There's a little splash screen, and it informs you to connect it up to channel 1 on our CBL or LabPro, and the amplification switch to high. And here is the screen from which we run the 2 experiments. We'll be running field and current first, and then after that field and distance. So we'll select number 1 here, and it asks you to remove all the magnetic fields around the probe, and then press enter to zero the probe. And for this first experiment, we will be collecting 10 data points, and the current for the very first trial of this experiment is 0, and then it says press enter to measure the field intensity. So once I push enter, it'll measure that field, stored in the calculator's memory in the stat edit lists, and then it goes on to trial 2. And in trial 2, the current will be 2 amps. And then it says press enter to measure the field intensity. And then the third trial, and we just keep going up by 2 amps each time till we get to 18 amps. Once the experiment is completed, the data is stored in the lists in the calculator. You press stat and then edit. On your left-hand column is the manipulated variable, in this experiment the current. And in the right-hand column is the corresponding magnetic fields for each of those currents.
The field strengths are in milliteslas.
Here is the rest of the data for the experiment, all the way up to 18 amps of current running through the long straight wire. You can now graph this data to find the relationship between the current flowing through a long straight wire and the magnetic field 3 centimeters from that wire. For the second part of the lab, use the same program. And at this point you choose field and distance, which is number 2. Again, it says to remove all magnetic fields from the area and zero the probe. In this experiment, you will be collecting 8 data points. Trial number 1 says at what distance, and we're going to begin at 3 centimeters. And then press enter to measure the field. Now make sure you have your power supply turned on. We're going to keep 20 amps of current through this apparatus in part B of this experiment. Next, we move the probe out to 5 centimeters of distance. Again, the power supply is generating 20 amps of current. And press enter to measure the field intensity at 5 centimeters. And then 7 centimeters. And so on and so forth until we get up to 17 centimeters. Remember, each time you move the detector to keep the detector vertical, keeping that white dot straight up and down. Keep the detector pushed up against the ruler to keep it going along the Earth's north-south magnetic field line. Now, after part B of the lab of distance and field, here is the data dumped from the CBL or Lab Pro into the calculator. The left-hand column is the manipulated distance, R, in centimeters, how far the detector was from the wire. And the right-hand column, L2, is our responding variable. That's the intensity of the magnetic field at those distances.
In milliteslas.
Please record this in your data table for this experiment, for this part of the experiment. And here's the rest of the data for the experiment. Now, with the data from this lab and the previous lab, use your graphing analysis techniques to find the relationship. First, between current and the magnetic field around the wire, and second, how the magnetic field varies the further we get away from the wire.